Hi everybody, and welcome to the next episode in the FLL must-have series. In this episode, we're going to be taking out what we did last time and then improving it for anybody to use. So, if you might remember last time, we wrote this wonderful Calibrate over here. And on our robot, all we had to do was press the button 3 times in order to calibrate our entire robot. However, if someone completely knew where to pick up your robot and run the program, would they know what to do? And perhaps more importantly, if you're in the middle of a competition or if you're trying to calibrate your robot, how do you know your numbers are saved? Like, let's just assume your laptop or whatever other device you're using to program isn't there. How do you check your values? Well, today we're going to be putting things on screen. We're going to be putting the information that you see on the computer, like these comment blocks. We're going to be taking the numbers that happen or pop up when you hover over these and put them onto the screen, put them into a table just so you can view them in a clear and precise way. So we're going to start off with the simplest thing. We're going to be writing this text and this text, so the put robot over white area and the put robot over black area text, on the actual robot screen. So let's see how we do that. First of all, go to the display button or the display block, because that's the one you're going to be using to, well, display the text over the robot brick. And what you're going to do now is you are going to go to text, and we're going to use pixels for now. There's two types, pixels and grid. If you're not familiar with it, it's basically up to personal preference, but of course I like to use pixels, so we're going to be using pixels. Once that's done, you want to go into the text block where it says Mindstorms, and here you can type in the thing you've typed in here. So I'm actually going to just type put robot over white area. You can use any formatting type you want, and what we're going to do actually for here is you're going to click on this small display preview in the top left corner of the block. Click on it and you can see our text. So this area right here, this box, is actually our robot screen, and you can see the only thing we see is put robot O. That's because the rest of the thing after put robot O is cut off. So we're gonna have to do something about that. There's two ways. One, you can decrease the size of the text, but the other way to do it is you can copy over another block, which I'm going to do right now. And what you can do is you take the O and whatever's behind, like after O, delete it, and you can put the same thing right here. And you might ask, well, why does this make a difference, right? You're just going to do that. Well, and also area is supposed to be in another block, so I'm going to put it again. We're going to delete over white because we already have that, and we have now area. So you might be asking, well, you have put robot over white area. But how do we get it to actually read put robot over white area? Well, you change the y-axis. So this will shift it up or down depending on your number. So let's just try 25. 25 actually isn't bad. So we're actually going to do 50. So we want it smack dab in the middle. We want to put robot a little bit off the edge over here. So we're going to do maybe 10. That's good. And we're going to make this area a 90. Right? And we want all of these to be centered. So we're actually going to put X as 15. We're going to put X as 15 here as well. Actually, no, we're not. Because over white is a larger amount of text and it's wider. We're going to make it like, we're going to mess around with the values here. Like probably a 9. I'm going to make it a 9 or an 8. 8.5, how about? And for area, we're going to push it over about 50. 60. 55. Yep, perfect. And the thing with using this method of displaying text is you don't want to erase the screen. Traditionally, how this program would run, and I'm going to run it right here, it's going to do put robot, it's going to flash over white, and it's going to flash area. It's going to delete the put robot, it's going to delete the over white, and the only thing you're going to see is the area, because these two execute in a millisecond. So I'm actually going to run this, and we'll see what it does. So I'm actually going to run it on here. As you can see, Calibrate, click on it, and we see area. But if you looked really closely, you could have actually saw put robot over white area. But it all cleared. And that's because the erase function basically clears the screen from any other display blocks from before. So let's go back to the computer and see how we can resolve this issue. It's quite simple, actually. Our issue right now is that it doesn't want to clear the screen. So you go to the clear screen and set it all to false. So what this does is it leaves everything from before on the screen. And back here, we're also going to add more display blocks. So what we're going to do is we're going to clear the put robot over white area as soon as we click the button. So in order to do that, grab a display block and you just want it to clear the screen. And in here, in the text, you're just going to put a bunch of spaces. And if we click over in the preview, we get our blank screen. This is how you make a blank screen in our program. So we're running the program that we had on our computer, right? And we notice a problem. Even though it has put robot over white area, we can see the background of our menu screen, which is this screen. Like that. And that's a serious issue, right? Because no one wants to see this jumbled mess on your screen. The reasoning behind this is because we told it never to clear the screen beforehand, it hasn't cleared the screen. And this background actually is coded into the brick as a screen. So you're never actually clearing it. You're just writing text on top of it. Luckily, there's a simple error to fix this. And I want you to remember every single time you have this issue, you're going to implement the solution that I'm going to show you right now. This issue, like the last one, is pretty easy to fix. All we have to do is set the clear screen back to true, but only for the first one. This allows us, when we write put robot over white area, to clear the screen previously, which ultimately gets us what we want. So click the play button and check the program. Of course, now run this program, and you see we have put robot over white area. And now if we put it on the white area and we click it, it doesn't have to be on the white area, but this is what you're going to be doing when running the program. Click on it, and it shows a blank screen, which is perfect because what we're going to be doing with this white screen is we're going to be displaying the values. We're going to be ensuring or telling the user that, hey, you've actually saved these values, and that's how the user knows that the robot has calibrated properly. It's actually going to show the high value on the screen. Now we're back to our computer. And now what we're going to be doing is we're going to be replicating the same thing, except now we're going to be putting the value of our sensor onto the screen. There's a few different ways you can do this, and I'm going to show you basically two of the most common ways you can. First of all, you want to grab one of these display blocks. I'm going to grab a fresh one because it's just a lot easier to customize. And so here, we're going to have our number. And you're going to, again, go to text, pixels, or grid, whichever one you like. If you've used grid, by all means, keep using grid. I'm going to use pixels for the sake of this. And for the text, right, you normally can type something in here. But you notice something up here that's called wired. And this wired thing, it allows you to wire a text to it. And not only text, but also numbers. And every single text like module, I call them modules, you can see there's a square on it, right? You can plug in any of the circular ones or numeric ones into that as well. So I'm actually going to put it after here, after it's actually read the value. And the first version I'm going to do is I'm going to take the high value because it's already in the variable. I'm going to read it and I'm going to plug this, oops, not text, numeric. I'm going to take the high value and I'm going to plug it right into here. And now what that does is instead of showing a text like that we type in, it's going to show the high value. Open it up, you're going to see the wired 1 FAC2 on it, which is not actually one it's going to show, by the way. It just shows that because it doesn't know what high is right now. So you're going to do that and you're going to center it. So because we're assuming that it's a value between around 80 and 100, it's a 2 to 3 digit number. So I'm actually going to assume that it's a 2-digit number. So we're going to move it over to X, however much. I'm probably 50. So just mess around with this. Make sure, try to get it in the middle. It just looks a lot better. I'd say 70 works pretty well for our purposes. And I'm going to move it down by 50. So it's right in the middle. And so now we have the first way of doing it. Now, the second way of doing it is I'm actually just gonna keep this to the side. We're still gonna keep it, but I'll just leave it over here. The second way of doing it is basically by taking another measurement. Now, I don't like this method as much because I just think that it's a lot better to know that your variable is saved and read it directly from the variable rather from the color sensor. But some people like to do this as well, which is take a second reading from this and put it into a text, the exact same text block. So it looks like this. Now, there's nothing wrong with this per se. I just like to read it directly from the variable. Some people just like the ease of convenience of just dragging another wire into the text box. And of course we have the same thing, so they should produce the same value. It's just a matter of preference. I'm just showing you both just so you can decide what you can use, and hopefully if any of the judges in FLL or anyone asks you how you got to this conclusion, you can explain why. So I want you to run the program that you used, right? So I'm actually going to delete this one right now, and I'm going to add my old one back in, just because I like it better, you know? It's a pretty biased judgment, but I like it better. So here it is, and I want you to run it. And now you should see your value on your screen. Now we can see here, running the program, we have put robot over white area. We're going to do that, and now instead of a blank screen, you're going to see a value here. Mine's 100, which is fine. Anything between 80 and 100 is fine. As long as you have something that's reasonable as a white value, your program works. So now we're going to go back to the computer and replicate this except with a black surface. Before we move on, because we deleted this clear screen block up here and we rather replaced it with the function of clear screen true, you can also delete this. I'm going to rewire it quickly, and instead on this display block you're going to put the erase screen to true. This way you cut out some blocks from your program and you make it more streamlined. Now you're going to do the same thing as you did when you put your robot over the white area. You're going to have the same display, except it's going to say put robot over black area. To do that, you can copy this over, put it after this weight block. And what you're doing now is, after you've confirmed your value for your white area, you're going to do the same thing for the black area. Now you're going to change the over white to over black. And here's your display for black area. Next, you're going to be copying over the read function, so you're going to read the number plus the wired block in after it's done reading the value for black. So you're going to copy it over, put it right after it's done reading the variable, and of course you're going to change your variable from high to low because you're reading now from the low variable, which contains the reflected light intensity of black. Now you can run this program and I'll show you what it does. Now we're running the program. Put the robot over white area. We're going to get a value of 100 just like we used to. Put it over again, or confirm it just by pressing the center button. Put the robot over black area, and I'm going to do that right here. And we're going to get a reading of 6, which is actually perfectly reasonable for a black value. This means that it works properly, and confirm it one last time in order to finish the program and save the values for real. So now you have the whole Calibrate set up to your wishes. So this is our final program. You can see there's a lot of green from these display blocks, and after that it's basically our basic wait for break button pressed, and then we have our read functions, wait for more, and then read from the color sensor, stuff like that. This is the Calibrate that most teams should use in FLL. And I'm saying most teams because this is still a more manual Calibrate. There's fancier ways of doing it and more accurate ways of doing it, and I'll be getting to that actually next video. But this Calibrate works extremely well for most teams, and especially it's easy to operate. It has the same benefits as I stated in the past video, which is that it's fast to program, it's easy to program, and it's easy to run, etc. Thank you for watching this Calibrate video. To see the previous Calibrate video and the basis to this video, click here. Be sure to like and subscribe, and check out my channel for new EV3 and FLL content. Until next time, bye bye.